Today, for the speaker for the session is Johan and Thijs, and they're from Zomnia. And the next voice you'll hear from is Johan.
Thank you. Hey everybody, I see a couple of people standing over there. We do have seats here in front, don't be scared. All right, so the gist of this talk is that we recently converted a large code base, say about 20,000 lines, from Pandas to Polars. And by doing so, we achieved a staggering cost reduction of 98%. Wow. And also, not unimportant, we also got a more maintainable code base. And if you're interested in how we did this and the lessons that we've learned along the way, then you're in the right talk. First, I should give you some disclaimers. Right? The code base that we started with also included some R. So you should take the numbers that we're presenting with a grain of salt. Yeah? I mean, I love R. I'm all for a polyglot approach to things. But in this particular case, it was definitely hurting our performance and also the maintainability of the code base. Yeah. So it's also not a Pandas to Polars tutorial, right? If you're interested in that, you can read chapter 3 of our book. What book? Well, this book. That's right. Thanks to this project, we fell in love with Polars so much that we decided, all right, this tool deserves a book of its own. So, and that's what we're currently writing, Python Polars Definitive Guide. And if we make the deadline next week, then the book will come out in February. So, and if you really can't wait, you can visit polarsguide.com. On there, you'll be able to get early release PDFs. So, chapter 3, if you're specifically interested in, converting some of your code or all of your code from Pandas to Polars. So, a few words about ourselves. My name is Jeroen Janssens. Over here, we have my colleague and co-author, Janssens Nieuwdorp. We both work at Zomnia, a data consultancy based in Amsterdam. And a fun fact, Richie Vink, who has kindly agreed to write the foreword of our book, also used to work at Zomnia. And he'll be giving a talk about Polars later today, which I can really recommend. Polars, right? Very briefly, because I've learned again and again that that increasingly more people are actually familiar with Polars. You know what? They're just two things that you really need to know. Yeah. So Polars is blazingly fast. We have been running a number of benchmarks. Benchmarking is hard. If you're really interested in how we did this, come see us after the talk, and we'll tell you all about our process. But yeah, it's actually quite obvious that Polars is much faster than Pandas on, every query presented here. Note though that the x-axis is on a log scale. And the second thing you should know is that Polars is getting more and more popular. Here, I've plotted, using plot9, I plotted the GitHub stars of a variety of data processing libraries. And while popularity in itself is, of course, not a goal, it does say something about how many people are using it, and also, thanks to the Lindy effect, how long it will probably be around. And when you're investing in a new technology or a new tool, you want to be certain that things will be around, right? That there will be a community where you can ask questions, and this is now, I'm pretty sure that most of you are familiar with Polars, But a year and a half ago, this wasn't really the case. And I'll talk a little bit about that as well when we had to convince the team. But we also had to convince O'Reilly a year and a half that Polars was really worth their time. Okay, so a few words then about the client, where Thijs and I both worked, and the project that we were working on. So we were working at a company called Alliander, and Alliander manages over a third of the electrical grid in the Netherlands. I know the Netherlands is only a small country, but these are still, decent numbers here that we're dealing with. So, over 3 million connections, both commercial and residential, right? So there are what we call 35,000 networks, on which companies and houses are attached to. And, oh wow, 1,000 are added or renewed every year. And then over 30,000 miles, did you put in miles? That should, of course, be 158 million feet of cables in total. With over 20 million inches added each year. Okay, so here's the current situation. Red means there is no more additional capacity to transmit electricity, right? And in practice, that means that we have to deny requests for installing solar panels, heat pumps, and charging stations for electrical cars. Not to the not to ordinary houses, right? They always get accepted, but large corporations or groups of apartments, we just have to say no. There's no more space on our electrical grid. They're being waitlisted. And so this is a huge problem. Alliander has to renew somehow the entire network over the next few, well, say, decade or so. And you can imagine that this is a very costly and time-consuming operation. And the big question is, where do you start? Which network of those 35,000 do you improve first? Now, this is where our project, the Delphi project, comes into play here. So here's a prediction of one such network. We're looking here at the street level, right? Individual houses are being displayed, and again, red is bad, right? So this is, we have to go from a reactive to a proactive way of working. So, oh, this is animated, by the way. You wanted to? Yeah. Hey, so, in order to make these predictions, we have to process, let's say, an entire network. And the before situation was we had this massive code base that consisted of both Python and R, and everything in Python was taken care of using Pandas. It took 5 hours to process one network. We could only sample, right? We were combining lots of data sources, and we have to do some sampling there in order to make a reliable prediction. We could only take 25 samples, otherwise we would run out of memory. Now, right, spoiler, we can do 50 easily, and this process, this single process, took over 500 gigabytes of RAM. So our costs were enormous. And we heard from upper management, like, hey, this is what we want to spend on this calculation. 5,000 euros, it's about the same as dollars, for processing all 35,000 electrical grids. How are we going to do this? So, of course, Thijs and I, we had an idea of what we could do there. We learned about this wonderful new data frame library called Polars. However, while Thijs and I were convinced of the power of Polars, the rest of the team, that was less the case for the rest of the team. So we have 3 things working against us. you can imagine, right, or imagine that it's a team of, say, 6, 7 developers, and 3 of them come from Xamia. We had another colleague working with us from Xamia. And all of a sudden, these 3, they say, hey, you know what? Let's use this early data frame tool that has been developed at our company. So you can imagine that you know, the team wasn't easily convinced by just that. Yeah. So at the time, Polars wasn't really well known just yet. Right? We're talking about a year and a half ago. And there was no stable release yet, no 1.0. So, what did we do instead? What we did is we searched for some low-hanging fruit in our code base, right? Some piece of code, some function that we could isolate and then benchmark. So the first benchmark, just the Pandas code, and then rewrite that part in Polars, benchmark that as well, and compare the two. Yeah, so there were a couple of things going on. It's again not just Pandas versus Polars. Pandas was using RDS, which is an R type of file. Lots of heavy compression that took close to 20 seconds already to extract. So again, we cannot blame everything on Pandas, but you know the story is more like, okay, we really need to rewrite this code base. Originally it took 30 seconds, and once we converted the RDS to Parquet and rewrote the Pandas code, which is always eager, into a lazy approach using Polars, the processing time went down to 1 second. Yeah, so that was, that's actually our first lesson. Show, don't tell, right? Our opinions don't really matter, just show the hard facts. And what also helped is that, and this is, of course, more subjective, is that the syntax of Polars is much nicer than that of Pandas. Again, it is subjective. But of course, we presented that as a fact. Okay, so that's one thing that we've learned. Now I would like to give the stage to Thijs to share, well, the rest of the process and other things that we've learned.
Yeah, so with that first benchmark, we were able to at least convince the team to give us some time to start working on converting some parts of the pipeline to see where we can get the biggest wins out of it. But as we went along, we also saw Pandas using a NumPy backend and Polars using an Arrow backend. You just have stuff in memory like twice. So if eventually we would converge on one library, guess which one it became. And along the way, we had many things that we ran into, like some small tips and tricks that we found out that helped us a lot. So the first one I wanted to dive into, which is something that can be kind of something that's obvious, but it wasn't to us at the time. Benchmark all the time. Just start with benchmarking. Every time you make some changes, benchmark another time, see what changed, how much RAM did it use, how much time did it use, if there's differences in the code, you can see like, okay, what changed around. So a couple benchmarks for some smaller sections that we eventually started doing. Was like for a very small example, it's already, it took like over 35 gigabytes of RAM. And we started swapping stuff around to, instead of loading all data in memory at once, to only start loading the data in memory that's necessary, kind of batch it, which already reduced RAM by a lot. And this gives you the ammunition to both optimize your infrastructure for it, but also show management like, hey, just this simple change, it's not a lot of effort, but it saves us a lot of money eventually. You're able to kind of showcase your worth and make the business case. And especially since we had this thing, we started scaling it up to the bigger clusters. So this is one of the jobs that we did for the 25 samples, one of the old school ones. And this is on AWS. So you see it ran with 465 gigabytes of RAM used, which is quite a beefy machine you need. And after this change, we reduced that all the way back to 75 gigabytes of RAM, which saves a lot of money because you can just practically run on the same types of instances. You can just run way more jobs in parallel. So it makes a massive difference. And just on top of the seeing better or the kind of changes make a difference, you can see what the business impact is. So like, hey, how much did we actually save? But another one is it can help you prevent regressions. So while we were writing the book, I was trying to see what the performance differences over different versions of Polars were. And the different lines you see are queries in a benchmark. And as you can see, the jump between 1.1 and 1.2, you see that there's a couple queries that have a very peculiar uptick, where you'd expect stuff to get better, right? So that's something that popped up because of a benchmark. And eventually, using some git bisect magic and all the fancy tools that we were able to track it down to a specific commit. And even the Polars team had no idea why that commit was causing it. And luckily, they recently fixed that one, and now it's ticked back down again, and it's quicker than it was before these releases. Luckily, so it can help you catch stuff like this too, which can otherwise go unseen. So the next lesson: work lazy, not hard. I'm not sure if you heard about the lazy API. It's something that Polar supports, and it's one of the biggest features, right? It's just upfront gathering all the stuff you want to do. Can give Polar the information it needs to just not do the work at all in the first place. There's a lot of stuff, a lot of data you don't need to load, a lot of computations you don't need to apply to that data, so it just you get all the optimizations ultimately lead to a big difference. And it's also, so Polar has an eager mode. We compared that with the lazy mode. And if you benchmark that, again with the logarithmic scale, you can see that the eager API, while still faster than some other data frame libraries out there, makes a big difference compared to the lazy API. So it's just always, if it's possible, it helps to build up your computation graph lazy and then collect it last minute so you have all the optimization capacity. This also brings another thing with it, because building everything lazy doesn't always work, we noticed. So it can help to work, to process through your stages and kind of cache the intermittent result. So if you have a very, very simple query, you have just something like this, and you can see that at the bottom, like both of these filters, both operations, they use the same underlying data frame. And the optimizer of Polar picks up on that, sees it as a common subplan, and says, okay, I'm going to do this once and just cache it. So both of these branches in the execution graph, they can just use that cache one, so we don't have to load the data twice and apply all that stuff. But in our application at one point, this is what the query graph looks like. So it gets understandable for the optimizer, it's not magic, right? So it's at one point, you still see some of the subtree here are still being cached, but what goes on above here is just, it gets stuck. And for now, one of the things was that if you start pulling all of this together, then it just starts in parallel loading all the data, and takes way more RAM than, like at the peak, than if you were to, for example, first this little bit and cache what's necessary, which is usually way smaller than all the data required to get to that result. So with your understanding of the code, you can kind of catch the intermittent stages that you use to reduce the peak amount of RAM that's necessary. And the way you can do that is that swapping between the eager and the lazy API is relatively simple. You've got two methods. So if you have a lazy frame, which is the data frame variant for the lazy API, you can collect it and get the result of the RAM, turn it into a data frame, and you can make it lazy again with the .lazy. But you can use this as a little trick to, for example, if you have some code, this is a very toy example, of course. You have a lazy frame, and say if in here, in between, you do some heavy computation work. If you were to use this calculation, like the lazy frame with the computation in it, and do something on it, and in another branch also use this lazy frame and do some other computation on it, here you have two collects. So that means that the heavy computation is done twice. It's done on the first calculation and it's done on the second calculation. And obviously you don't want to do the same work twice. So with that knowledge, it's practically the same. The only thing you put in between is a collect and lazy call. So this means that this heavy computation and everything everything in the plan at this moment is all collected, it's run, it's computed, there's the computation going on, and it's saved into RAM. And then made lazy again. So after this point, you still can make use of the optimizations that the lazy API supports. And this way, the heavy computation is done once. These can make use of it exactly the same way, but it's just kind of like a caching. It's not literal caching, but it's kind of like the spark persists for a time. So one of the big deals that we found out as we were using Polars is that Polars has a lot fewer surprises, especially compared to Pandas. So I think it's also another talk was also about comparing the different data frame libraries on this conference. One of the things is, of course, Pandas has multiple representations for the same types of data. So one example is, for example, for the strings that we have. Because it uses NumPy as a backend, it stores Python native string objects in the NumPy array. That's the object that you may well know. You also have the string D type, which is an extension type. But on top of that, you have another string D type, which is an arrow type, which we recently supported. So we have different kinds of string D types depending on the situation you're working with. And in Polars, Polars is just built on the arrow, the arrow interface, which is also made by Wes, of course, after he left Pandas. And with the knowledge gathered from how Pandas was kind of needed a unified way of dealing with data types like this, Polars now just has string. And that you don't have to swap between the data type forms, different representations, just always string, which makes it a lot easier to deal with storing your data types. On top of that, per data type within Pandas, you have, oh yeah, of course, I'll move to that one, next thing. So another one is the Polars uses the index, of course, or a multi-index if you want to go wild with it. And this causes some unexpected behaviors here and there. So for example, sometimes because stuff is aligned on the index kind of under the hood, so you don't necessarily see it. So with you can get some incorrect joins, you get unintended nans. You have some reduced flexibility, especially when reshaping or filtering certain operations. You have to start dropping the index or resetting it, re-indexing files. So Polars doesn't have that. It just doesn't use the index at all. So you don't have to reset index drop through. And this is one of the things that we saw in Pandas. So if you have a very small frame, it's unsorted. So you have like the 3 in the middle. And if you were to want to sort this, you would say like, okay, so I want to replace the first column, and I just want to sort the values, right? So if you replace it with sort values of this, you'd expect my column's sorted now. But under the hood, it aligns on the index. So practically it sorts the values and then sorts them right back according to the index. So nothing happens. Well, it did sort in the meanwhile. So it's just an expensive no-op. And this is something that, just a toy example, of course, but there's multiple examples where the index kind of comes at you in an unexpected way. Tying back to the data types, depending on the data type in Pandas, you have a preferred marker for missing values, which can get wild sometimes. In the new arrow data types, at least you have the NA value, which is just the general missing marker, but especially the older types, numerics, floats, for example, uses a NaN, which is actually a value that indicates that a mathematical operation didn't work out correctly. So it's not a missing value necessarily, but there's no other way. You don't have the Python num that you can put into the NumPy object. And there's some other stuff like this going on. Luckily in Polars, you just have all the data types have the same way of indicating a missing value. So there's like on top of all the data and the array of series, you have a validity map which just said is this value here or not, and that just marks is it null or not. On top of that, you also have the NaN is not a missing value anymore. It's specifically like, for example, if you start dividing by 0, then you get a NaN because it's just a mathematical operation that doesn't work out properly. But that's not a missing value. Those are separate things. Next lesson. Take baby steps. So just like what we saw with the benchmark, we just grabbed a very small piece of pipeline, and we were able to swap it out with a little bit of Polars. And you can start focusing on the areas that need the most improvement first, like that have the most gain. It's like when you're doing many joins, if you're doing kind of expensive group by operations, those are the areas of your program that benefit the most from the parallel processing and optimizations of Polars. And stepping between Pandas and Polars is relatively easy, because if you want to go to a Polars data frame, you can just call the initiator of the Polars data frame. Just drop your Pandas data frame in there, and it just gets pulled into Polars instantly. And if you're lucky enough that your Pandas data frame has the arrow backend, then it's even 0 copy. So it's very quick. And if you want to go back to the Pandas, you can just get your data frame and do it to Pandas, just practically as you would go to NumPy arrays or other forms. You just swap very quickly like this. And the last big lesson, which helped us a lot, joining the community. There's a Discord server of the Polars team, and it's very active, both with the devs themselves, but also other people that are jumping in to answer questions. And we've helped out answer some questions, or tried at least, and also had our questions answered on this community, which has helped a lot. So this is the aftermath of the benchmark I showed earlier, the small regression in performance. That after they pushed the fix, I ran it again, and you see that like now it's quicker than it's ever been. And it was very quickly picked up. Even the Polars team have some changes on the inside to try and prevent regressions like that again. And they even optimized, I think, their git bisect tool, so now they can compare all kinds of, like the last 400 commits, he said it can be checked within 6 seconds to see which commit it was that caused the regression like this. So they've really optimized their infrastructure because of this. So, looping back to the Alianda project. After having applied all these lessons and having all the optimizations that we brought to the project, now finally, after that time, one net takes 4 hours, so we have a reduction of 20% in time. It can finally take a target of 50 samples, after which the results start stabilizing more, so we can do twice the amount of samples. It uses 40 gigabytes of RAM, which is a 92% reduction in RAM. And the code is finally fully in Python, and we don't have to use the ARPA2 interface anymore. And on top of that, it's fully in Polars. And all of this results in that we're finally capable of calculating the entire low voltage grid, which is the 35,000 nets. And that, for a cost of 70% of the cost. And if we made a comparison of recently we did those calculations for the entire low voltage grid. And if we were to have used the code that we had 2 years ago, it would have cost us 140K. So that's quite the difference we made. And this is also obviously something that you can go to management with and post with. So this is something that we're very happy with to have achieved. And on top of that, one of the things we learned is we came for the speed and we stayed for the API, which is definitely something that grew on us, and it's very easy and ergonomic to work with. So to line it up one more time, the lessons: show, don't tell. Just anytime you want to convince people, just show them the numbers. Don't start with opinions and this library is better because I think. No, just show them it's better factually. Benchmark early and often, after big changes, just benchmark it, see. Kind of ties into the show, don't tell. It's see what changes you made in the numbers. Use the Polars Lazy API. It supports a lot of optimizations. It's definitely worth using. And balance that out with staying smart with it, so you can cache on the right moments in your pipeline because you know more than the data frame library does sometimes. You have to tell it okay, so here, save the data. There's a lot fewer surprises and more consistency in the way Polars manages the contents of the data. And it's very easy to start small. You can easily swap between Pandas and Polars using the tools available in Polars. And it's always worth it to join the community. Thank you. Back to this one. Saw some people taking pictures already.
Guys, we have another 5 minutes for Q&A, and if anyone has any questions, you can raise your hands.
Very nice talk. I'm just curious as well. You had a fixed budget about how much you wanted to spend on the computation, but what about the personnel that's involved in doing this for you? You have limits on that, which take a particularly long time.
I think the questions about the budgets, there's a set budget for the computation, but the personnel budget, what about that, right?
Yeah, exactly.
I think the personnel budget is something that it's a different folder kind of. So it's something that the team set at a certain amount of people that were available for it.
Right.
And with those people, we had to get that target budget done. Yeah.
follow-on is more like, how long did this migration take? Like, how many like, was it 2 people over 6 months? Was it 1 person? You know, roughly order of magnitude. So.
Yeah, definitely. I would say about 6 months.
Yeah, the thick of it, yeah. So I've been with this team for 2.5 years, and before that we were still trying to convert some parts to both Python and Pandas. But ultimately when we started the switch, I think the biggest parts of the pipeline were done relatively quickly.
Also good to note that this was a binary thing, right?
Yeah.
We were able to produce results throughout the entire process because we took those baby steps. And we were able to swap out bits and pieces of Pandas, the Polars, and R, and Python, which of course makes it so that things take longer, right, to convert everything, but we're still operational.
And it's also the classic thing of, it's kind of tech dev-ish, right? Because we had to build additional functionality into the tool, but at the same time, just replace, swap out parts and keep the functionality the same, so defending that the decision against business. So it happened both, but I think the total time is about that. Yeah.
So currently, is your entire code base now in Python since you switched over to folders, or is it still in R?
No, it's we completely removed R. I think there's a pull request somewhere where we use like the surgical term ectomy, like R-ectomy, to finally clear everything of R and remove the dependencies, remove from the Docker files, everything, which just reduced the image size a lot as well. Yeah.
For the other people on the team, how long did it take them from, okay, I have to use this, to I'm comfortable and now I'm going to use it as my default tool? Did they get there, and how long did that process?
Yeah, but by now, I think at least one of the other devs is like very much a proponent of Polars even within the organization, became like an ambassador. I'm not quite sure how long it took it.
It differs per person, right?
Yeah.
Others are more interested in learning new things than others, and so it is definitely there's definitely a learning curve. Right? If you're so used to Pandas, which has been around for 15 years, and all of a sudden you have to get used to this different API, yeah, it takes time. Luckily, as we were writing the book at the very same time, so we were one step ahead of the rest of the team and were able to take them along on this.
Onboard them. Yeah, and in the meanwhile, there's some new developers that came onto the team, and they did like even some juniors that just don't know Pandas a lot. And they're even onboarded in Polars and just very quickly up to speed with that.
So for the benchmarking part, how do you guys determine where to start and then kind of the steps to go forward? Like, did you have a plan set or?
Yeah, so it's a question about the benchmarking, where to start. So we just had one very relatively simple piece of the pipeline where we just had the main data frame. We had to gather some data from the cloud storage and just join it on top of it. And that's where we started. So that's a very, very simple, relatively simple piece to start working on. That's one of the things we just tried out.
So like
After that, once we had convinced the team, of course it's still a matter of, okay, what do we tackle first? Same as Aliamba has to decide, okay, which network do we reinforce first? We have to decide, okay, which piece of code do we fix first? And so what we did at the very beginning is we profiled the code so that we could produce, we could really learn where most of the time was spent. What was the next low-hanging piece of fruit?
Yeah.
So if you didn't like see the results you wanted to see, would you guys have continued or?
I think ultimately the numbers don't lie. So if it turns out that Polars would have been slower, then yeah, we're not going to force that. But it just didn't because Polars is very fast.
yeah, we were quite confident, especially thanks to the initial benchmark.
Yeah.
So would you recommend for high memory production memory settings? So like, I wouldn't want to take this switch for EDA level stuff like that. Pandas is good enough, or what would you recommend? Is Polars just good enough for everything?
Yeah, so at this point I'm using Pandas for everything. Even EDA stuff, you've got the eager API for an iterative way of working. And that's good, but like I said, like you come for the scheme, you stay for the API. So just even the EDA work is just a lot more comfortable and ergonomical to do using the Polar syntax.
And to add to that, Pandas also made this point yesterday in his presentation. If you have a code base in Pandas and it works just fine, it's not broken, then I wouldn't say there's a need to fix it, because it is still quite a big investment to do staying broken or fixing, right? Yeah.
Thanks for the talk. That was really nice. My question is, having gone through this process, is there anything that you would have done differently in retrospect?
Yes, for the things we would have done differently in retrospect is mostly like the benchmarking stuff. So we have had a way clearer view of which parts of the program made the biggest impact. And so you have some data to steer on that, right, to make better decisions as you go through the process. Because in the beginning, like we started out with some parts in the code that we were using in a couple of iterations, so that's why we started. But we never really got to see the impact of that. You just see like over time, like in the runs, you see costs go down, but you never really got a good feel for that. So I think that would be one of the main things I would change. But then again, I'm a data scientist, so I love gathering data about everything.
So a question about the book, is it the structure of the book, is it like project-based or case study driven, or is it more of a reference guide? How would you describe it?
I think kind of mixed it. I think we kick it off with a showcase just to show like this is what Polars looks like. But ultimately, it's more of the structured like chapters and introducing new concepts behind Polars, so different contexts that you can work in, the expressions. There's all kinds of just the main concepts form the chapters, and then within the chapters we've got a lot of examples, and every once in a while we throw in a use case to show a more practical way of dealing with it.
Oh, right. So it's not based on this successful project that you just presented. The book is actually separate.
Yeah.
Okay.
So,
got it.
Is there any processing done on GPU?
Sorry, is there?
Was there any GPU processing?
Nice.
Was there any GPU processing?
No.
Yeah.
Not in this project, because mostly the GPU engine is out for like 1 or 2 months, so we didn't get to use that yet. It can definitely be interesting to check it out, but as far as we've seen so far is that the GPUs make sense with very big data sets, and these are quite small nets. So we just have a lot of smaller calculations as opposed to one massive one, and that's I think where the GPU really shines.
Were there some pieces of the projects where you kept it in Pandas and you didn't convert it because you wouldn't see much improvement?
In the end, no. In the beginning, yeah. So there was some parts where we kept Pandas for just the longest practically, and at the end it was more of like a technical depth approach. That there were still some parts in Pandas, and swapping now with Polars didn't give it a massive boost, but it's just to keep the code base consistent. We decided to do it anyway, and to reduce like dependencies.
So you removed like Pandas library code with it?
I think we did at this point.
There was this one piece of ad hoc analysis that I had to do where I had to do some weighted sampling per group. That at the time wasn't the functionality that Polars supported, so I used the 2 pandas, the trick to convert to pandas and back, and you know what, it's totally fine. So, but as for the project itself,
yeah.
Thank you so much.
Sorry. Okay.